This video is on finding formulas for quadratic sequences. We've already covered finding formulas for linear or arithmetic sequences, and so in this video I'm going to show you a different type of sequence. First, in order to be able to find these formulas for quadratic sequences, you need to know how to solve systems of equations. We've covered that already, but just to review it, I'd like you to solve each of the systems that you see below, 1 and 2, in your notes. If you don't remember how to do something like this, then you can go and watch my video on solving systems of equations, which I've loaded on the blog as well, right below this video. So if you need a refresher, pause this video and go watch that other video. But I'm expecting that you write the answers to these along with your work in your notes. So you might want to pause at this point. Hopefully you were able to solve both of those systems of equations, and so now you're ready to find quadratic sequence formulas. A quadratic sequence is one in which the first difference is not constant. So when we were covering linear sequences, we saw that the difference between each of the terms was always a constant. We were either adding 4 each time, for example, or subtracting 5, but it was always the same between each term. In a quadratic sequence, the first difference is not constant, but the second difference is. That's what makes it a quadratic sequence. And to find a formula for the nth term, you have to use this general formula, which hopefully you're recognizing is a quadratic, which is why they're called quadratic sequences. So I'm going to do 2 examples on the next 2 slides, but make sure you have this note in your notes before you move forward. So here's our first example. This is going to be a quadratic sequence, as we'll see, but here are my terms. Okay, so if I were to list out this sequence, it would be 0, 1, 4, 9, 16. And so you can see that, as I told you in class, sometimes it's easier if we start listing the n values on top so we can see what the pattern is. Here it's a little difficult to see the pattern, and so we might want to proceed in a different way, which is to figure out the first differences. So we've done that already. The first difference, the difference between these 2 terms, is 1. The difference between these 2 terms is 3. The difference between these next 2 terms is 5, and then 7. And I know we saw some examples where this was the case in class, but we didn't really find the formula yet. Now, I start with this row. So I've already done the first difference, and now I want to find the difference of these, which would be the second difference. So the difference between these is 2, and these is 2, and these is 2. So now my difference, it's the second difference, is constant. Okay, so it wasn't the first difference, it was actually the second difference. That means since it's second, it's going to be a quadratic sequence. Since it's quadratic, I'm going to want to use this general formula. T sub n equals a n squared plus b n plus c. Okay? So in our linear or arithmetic sequences, we used this general form. We had some slope times n, and then plus some constant. So if, as we saw when we graphed them today, it was basically like y equals mx plus b. So this was the general formula that we were filling out today in class. Now we need to use this formula. The first thing that you'll have to do with this is look at the second difference. So it's equal to 2 right now. But in general, the second difference will always be equal to 2a every single time. Okay, so this number will often be 2, the common difference, but it's not always 2. But it does always equal 2a, which means that in this case, our a value is 1. So we can actually go to our formula right now and substitute in that this is 1. So that's the first thing we want to substitute in. And we can also substitute in some n values because we have an entire table of values up above. So for example, when n is 1, my term, Tn, is 0. So when I'm on my first term, T1, that means I get to fill in 1s for all of the n's, and I get to fill in 1 for a. So I really have 1 times 1 squared, which we could just say is 1, plus b times 1, plus c. And that is my first term. And what does my first term equal? my first term, if you look up, equals 0. So this equals 0. That's one of our equations. Let me simplify it a little. So it's 1 plus b plus c equals 0. I'm now going to get a second equation by using the second term. And so now my n value is 2. My a value is still 1. So if I'm going up to this formula and substituting these in, I have 1 times n squared, so that's 2 squared, plus b times 2 plus c. And that's equal to our second term. So if you go up to your table again, when n was 2, the term was 1. So my second term equals 1. So now I have this second equation. So here's my first equation. 1 plus b plus c equals 0. And here's my second equation. It would be 1 times 4, which is 4, plus b times 2 is 2b, plus c, and that equals 1. So again, we have a second equation. And hopefully now you're finally seeing why I had you solve those systems of equations problems at the beginning, because I have two equations with two unknowns. B and C are my unknowns, and I'm now going to go solve them. I'll do that on the next slide. So I'm going to use the elimination method to solve this system. You could actually use substitution if you want, but oftentimes with these sequences, elimination method will be easiest. I could solve this just like it is, but I'm going to rewrite my equations so that I have my b and c term on one side and my constant on another. So I'm going to move the 1 to the other side. So this is b plus c equals negative 1. And in the second equation, I'm going to move this 4 to the other side. And so it's 2b plus c equals 1 minus 4, negative 3. And hopefully you've noticed that if I subtract these two equations as they are, the c's will eliminate. So that's what I'm going to do. B minus 2b is negative b. C minus c is 0. And so that equals negative 1 minus negative 3, which becomes 2. So if negative b is 2, then b is negative 2. So that's one of my other variables solved for. Now I just have to get c, because if you remember, I already have that a is 1 from the previous slide. So to get c, I could take b, substitute it back in to either of those equations, but the top equation looks easier. And so we have b plus c equals negative 1, which is negative 2 plus c equals negative 1. I'm substituting in. And so we get that c is 1. So I have all three of my variables now. The goal of this was to get that general formula for the quadratic sequence, and that formula was this. So I have to fill in my different values. So it's t sub n equals a is 1, so I can just leave that, plus bn, which would end up being minus 2n, plus c, which is plus 1. So this is my general formula for finding the terms in that sequence that I gave you. Let's test it out by finding the third term. So if I want the third term, that means n is 3. So I'm going to put 3 in for the different n values. And that's 3 squared minus 2 times 3 plus 1. And that is 9 minus 6, which is 3, plus 1 is 4. And if you go back to your table, the third term was 4. So now we can be sure that this is, in fact, our formula. I'm going to do one more example on the next slide. Okay, here's our second example. I know this is a really long process, and it's okay if you didn't fully understand the first example. Hopefully by seeing me do a second example, it will answer some questions that you might have. So I'm asked to find a formula for the nth term of this sequence. The sequence is negative 3, 3, 11, 21, 33. It could keep going. So that's my sequence. And obviously, these are examples for quadratic sequences, so it's going to work out that we need a first and a second difference. But you could do this process in general. So the first thing I'm going to do is find my first difference, which is 6, and my second difference, which is 8. My third difference is 10, and my last difference is 12. Okay, so that's my first difference, and it's not constant. Therefore, it's not linear. So I have to go to the second difference. You want to keep going until you get a difference that is constant, and that's going to be here. we will actually do one where we need a third difference in order to get it to be constant. But here, the difference between 8 and 6 is 2, and 10 and 8 is 2, and 12 and 10 is 2. So my second difference is constant, which means this is a quadratic. So now I'm going to use this general formula again. Every time you have a second difference that's constant, you need this formula for quadratics. And again, this second difference is always equal to 2a. That might have been a little confusing on the previous side, but all you need to remember is that the second difference, no matter what this constant is, if this was 4, 4, 4, then my a value would be 2, because these values are always equal to 2a. So 2 equals 2a, which means a is 1. But if this were a 4, then a would be 2, and so on and so forth. So I can automatically fill in my a value is 1 in my formula. After that, we had to get 2 other equations, because even though I know what a is, I still don't know what b and c are. So that's 2 unknowns, which means I'm going to need 2 different equations. So we go to our terms. I know my first term is -3. That's coming right from the table. So my first term is -3, and that's equal to a, which is 1, times, I'm in my first term, so n is 1, plus 1 squared, sorry, b, which we don't know, times 1, plus c. So if I clean this up, we have that -3 equals 1 plus b plus c. And just like I did on the other one, I'm going to move that 1 to the other side, so my final equation is b plus c equals -4. So that's one of my 2 equations. And then we would have to do that very same thing again. And again, I'm going to use the second term. I could use the fourth term if I wanted to, but it would just make the numbers much larger than I need them to be. So in my second term, again, I'm substituting into my general formula. My a is still 1, but now n is 2. So I have 1 times 2 squared plus b times 2 plus c. And if I rearrange that, oops, I forgot to say that my second term, what my second term equals. So if you go up to your table, my second term equals 3. So this equals 3. And if I rearrange this over here was 4 plus 2b plus c. And so it's 2b plus c equals 3 minus 4, -1. So these are, whoa, sorry. These are my 2 equations that I'm going to solve on the next slide. Okay, so I have my 2 different equations. I'm going to again use elimination. If you want to use substitution, go for it. And I can see that if I subtract these 2 equations again, the c terms will eliminate. So I would have to do b minus 2b, which is -b, c minus c, which is 0, and finally -4 minus -1, which becomes -4 plus 1, which is -3. So since -b equals -3, b is 3. Almost done. We only have to go get c now, because again, if you remember, a is 1 from the very beginning. So I'm going to take my b value, go up to the top equation, and I'm going to put that in. So instead of b plus c equals -4, I'm going to substitute in 3 plus c equals -4, which would make c equal to -7. And now I have all 3 of my variables that I needed to solve for, and so I can finish this very long process. I need to fill them into this general formula because it was a quadratic sequence. And so the general formula for finding terms in this sequence is 1 times n squared plus bn, which is plus 3n, plus c, which is -7. And you could go test this out with your third or fourth term, and you would see that it does, in fact, work. Hopefully these examples were helpful. If you have any questions, please email me.